Hello everyone. My name is Vijay Shankar Tiwari. I am a PhD scholar in Department of Computer Science and Engineering at IIT Bhilai. Welcome to this tutorial on using Gephi for network analysis and visualization. Gephi is an open source tool designed for visualizing and analyzing complex networks. It is widely used in a field like a social network analysis, biology, and data science to explore relationship between entities. In this video, I will show you how to import a dataset into Gephi, visualize the dataset, and customize it to make it more informative. Whether you are analyzing social network, biological interaction, or any other kind of relational data, Gephi can help you to uncover pattern and that not be visible in a raw data. By the end of this video, you will have a clear understanding of how to use Gephi to analyze and visualize your own dataset. So let's get started. Before importing a data into Gephi, it's essential to ensure that your dataset is properly structured and clean. Gephi works with two main types of data: node data and edge data. It is also support multiple data formats like a GEXF, ZDE, ZML, NET, GraphML, DL, dot, but we are mainly focused on CSV format, which is one of the most commonly used format. But why we are using CSV format? So the CSV files are easy to create and edit using look like a Excel or Google Sheet. Make them a great choice for beginners. So the node table including ID, names, group information, while the age table including the source, target and strength of the relationship. But here we are not going to use that kind of data. We are directly import a graph data. Okay. So once your data set is prepared, next step to import it into Gephi. This involves loading your node and age table, configuring, setting and ensuring the data is correctly mapped. So properly importing your data set ensure that Gephi can accurately represent your network for visualization and analysis. So now I am going to open a Gephi file. So for opening a file, we have multiple choices like a new project, open recent, and we can also import a data set. So this time we are using open menu. So I have a GML format data, which is basically Chhattisgarh district data set. That is a real live data, which is where I am going to explain each one by one every step. So when we are importing data, we have multiple choices. Like we can create a directed graph or we can create an undirected graph. I'm going to, when I say a graph, I'm basically talking about networks. In a real life network, we usually denote it as a graph. Okay, for the visualization and analysis, we denoted networks as a graph. Okay, so I am going to start a new workspace for undirected graph. Okay, and there is some information given about the data set. First, there is a number of nodes which is 33 and there is a number of edges which is 73. Okay. So see, I import that data. Okay, but this data is not actually look great. So first I change it into some very good format. So there is a multiple layouts we have. So I am going to use this one. See, now my graph data or my networks looks much structured as compared to before. Okay, and now I'm going to calculate statistics of that network. So there is a multiple kind of information we can extract from the graph. So first I am going to calculate what is the average degree. So for calculating average degree, I am just going to run this average degree. So I have just need to tap on this run button. It automatically compute the average degree of that graph. So see, there is a average degree is 4.424 and there is a graph plotting. After that I am going to see what is the average weighted degree. So there is also 4.424 and we can also see a degree distribution here. And now I am going to see what is a network diameter. So for network diameter we have multiple choices like undirected, directed. We can also calculate a normalized centralized value. Okay, but this time I am not going to use a normalized value. So I am simply calculate it for a undirected graph. So my graph diameter is 9 and you can see here is also it give us some extra information like a radius is a 5 and average path length is a 3.579. Okay, so what is exactly meaning of diameter? Diameter is a maximum minimum distance of the graph. Okay, means we have a one node and for the whole graph I am going to calculate what is a maximum minimum distance of two nodes. Okay, and radius is a basically, and if you're talking about in a basis of eccentricity, so radius is a minimum eccentricity of that particular node which is present in a graph, and diameter is a maximum. Okay, and now I'm going to calculate graph density, means how dense our graph is, and we have to calculate it for an undirected graph, and our result is 0.138, that is our graph density. Okay, and with using we also calculate how many number of component present in the graph or our social network. So there is a connected component is a 1. There is, you can see also a distribution. After that we can also calculate in a Gephi average clustering coefficient. So what is the exactly meaning of clustering coefficient? So clustering coefficient basically denoted as how well connected your neighbors for any particular node, where their neighbors how well connected. Okay, so there is a actually average clustering coefficient is 0.468 and total number of triangles. In some point Gephi also give you some extra information about the graph. So in this time it calculates the number of triangle. So total number of triangle is 38 and that is a clustering coefficient distribution of the graph. After that I am going to calculate eigenvector centrality for the number of iteration. Here we can give a user defined iterations like this time it's 100, but I can change it into 50, and for 50 it is a 0.1377. Okay, and I can also change the value like 100. It's a 0.056278 and something. After that here automatically automatically it calculate path length. Okay, and this portion basically we use for a dynamic graph. What is a dynamic graph? Dynamic graph means there is a number of edges and number of nodes are changes dynamically. Okay, so when we are calculating this all centrality measures or importance or eigenvector centrality and something else, then here we also have, there is a one graph table we have. Okay, at the first we have only id and labels. id basically denoted as a number of nodes in a graph, where graph where first node is denoted as 0 and last node denoted as a 32, because there is a 33 number of nodes. Okay, and then we have a number of labels of the node, but when we calculate degree, then the degree table is updated by their self, and when we calculate weighted degree, eccentricity, closeness centrality and harmonic centrality and many more, it update by their self. We no need to update is manually. Okay, that is a self doing something kind of things. Okay, now I'm going to show you what are these tools here. Okay, so I am going to show you for using of every tool here. So like first I'm starting with a age weight scale. Okay, that is basically increase or decrease the thickness of the edge in a graph. I'm changing it in a maximum. That is a basically used for labels, and with using T I'm going to show you label. See, this is a change. That's how we change the size of label in a graph. Okay, this light button basically changes the background into dark, into light. Like here, this rectangle tool basically used to select a partition of a graph, and for this drag tool we can also drag any particular node to anywhere like that. Okay, and this is a very important tool where cursor have a question mark. Like if I tap any node, it show me all information about that node. Like I am tap a Durga district, this it is show me all information about that particular node. Like you can see size, stand, position Y, position Z, color, label, sign and many more. Okay, then I can also color it with a red, I can also change the color like blue. I change it with a blue. Okay, this tool basically used to change the size of any particular node like that, like that. Okay, this tool basically paint the node. This tool basically used to add a node. Like see, with using that tool I add 1 2 3 4 5 nodes there. I'm going to change their location. So with using this tool I can add a edge like that. I'm also going to change their size. I can also change their colors. If this tool I am going to use, it change the color of all connected component, and this tool change the color of only that particular node. Okay, this is basically show the distance, what is the maximum distance of that particular node. See, okay, now I'm going to calculate again what is the how many number of components there, and see there is a number of components is 4, first, second, third and fourth. Okay, I'm going to remove all these extra nodes. So I'm select it, just right click and delete. Okay, after that I am going to show you how do I change that graph in a basis of degree or eccentricity or weight or their clustering coefficient or something else. So for that, see, I am going to apply a partition in a basis of degree. So when I apply it, see, the whole graph is changed. Basis of it, I can also change the size of nodes. Okay, where I want to maximum size of a node is a 50 and minimum size of a node is a 15. When I apply it, see the maximum degree nodes is a bigger and the minimum degree nodes are smaller. Okay, it basically so when I tap that particular node, it just show how many neighbors that have. It just so it also can show their neighbors, only the connected directly connected nodes from that particular node. Okay, and also apply same thing in a edges also. Okay, there is a every edge have a weight 1, so it's not going to change, but I can apply. And we can also see some other layouts there like for LTAs. I'm going to remove their caption. Okay, for at force Atlas 2. I'm going to change their size to see the better view of that particular graph. See, that's how my graph is actually look like when I apply force Atlas 2. Yifan Hu. is also a one very good layout for the graph, and there is many more layouts. My favorite is a Frenchman Vision Old. When I applied it looked like that. Okay, so I feel like you understand every part of that Gephi. I'm also show you data laboratory. I'm just going to show you preview. And a preview, we just going to see how our networks look like. So there's a default preview, default, see how my graph is look like in a default view, in a default curve. I think not any change. I'm not. I think not any changes are here. Just adding a labels. See, there is a labels added. Okay, default state. When I use it, it state the edges. See, and there is a many more like a black background. But what we are going to do with it? Okay, then I am also going to show you the export format, means how many formats we can have to export that particular graph. Okay, so for export I am going to go in a export. Here I am directly export the whole graph data in a single file, and which format is CSV. When next I am going to open this CSV file, next time I no need to calculate that staticals for the whole graph. We, when I open this particular file, which the file already have all that information about the graph. Okay, and I can also export it in a SVG, PDF formats, like how my graph is look this time. I'm going to save it in a name of graph 1, and I'm just going to change the preview for the graph. Okay, I rank it a base of a degree. I can also rank it in a base of eccentricity. I'm also going to show the layouts, sorry, labels, based on their ranking, and the ranking is a degree. It not look cool, so I'm going to change it. Just partition it. Okay, now it look much better. I'm also going to change the edge color. Unique color, I'm going to change it on a dark red. Okay, see how my graph is actually look like now. And now I'm going to export in a, you can see there is I have a three formats: PDF file, PNG file, SVG file, where PNG file is basically image. So I'm going to save it as an image. Okay, and just going to change their format, not expansion. See how that layout look like, but not running, random layout. it also not look good. Now it look much better. I'm also going to remove their labels. Now I save it again in a PNG format, and I change their name to graph2.png. Now have a look how our graph look like. It's a graph 1. See how it looks. That is a graph 2. It's saved in a that curve preview format. Okay, so I feel like I explain you everything about that Gephi tool. So the conclusion of that Gephi tool presentation is, in this video I start by preparing a data set, then imported it into Gephi, applying layout, customize, visualize, and finally exported the graph. And Gephi is a very powerful tool for exploring complex network, whether you are analyzing social connection, biological interaction, or any other type of relation data. Now that you have seen how it works, I encourage you to try Gephi with your own dataset, experiment with a different layouts, customize your visualization, and see what insight you can uncover. For more information, you can also visit the official Gephi website at the gephi.org, or check out the Gephi wiki and community forms for the tutorials and supports. So thank you everyone for watching this tutorial. I hope you found it helpful and feel confident using Gephi for your own project. Thank you.